ciphertext is then converted back, and then the ciphertext has been converted back to the plain text through the decryption process. We have made use of various algorithms in this process, like the AES, DS, etc. Network security and cryptography ensures the confidentiality, integrity, and the availability of the data. That is, no unauthorized user can access the data. In confidentiality, the authorized user can only access the data. In integrity, it ensures the trustworthiness and the accuracy of the data. In availability of the data is been made available to the user throughout the process when it is needed. Further, we'll be outlining you about the algorithm, advantages, future scope, and in our research. Further, I request my team member Anushka to continue with the presentation.
In cryptography research has following types and algorithms are used for data hiding purpose. Symmetric key cryptography, asymmetric key cryptography, data encryption standard, advanced data encryption standard, steganography. We are studying mainly in image steganography. In symmetric key cryptography technique, in which only single key is used for the encryption and decryption purpose. This method is known for its speed and simplicity, but it has primary concern the secure transmission of secret key itself. Hence, both parties involved secure communication.
Asymmetric cryptography, asymmetric encryption, also called as public key encryption, is way to keep information safe. It using two keys, that is a public key and private key. When someone wants to send secret message, then use public key and to lock it and can unlock and read the message. They use a private key. These two keys are linked in a unique way. It's extremely difficult to figure out public key if you only have a private key, if you only have the public key. This method is considered more secure than symmetric encryption, where the same key is used for both locking and unlocking. Some common asymmetric encryption techniques, that is RSA, DSA, and PKCS. DES, that is data encryption standard. This algorithm process breakdown into the following steps. The process begins with the 64-bit plain text block handed over to an initial permutation. Then IP is performed on the plain text. The initial permutation creates two halves referred to as LPT and RPT, that is left plain text and right plain text. Each LPT and RPT goes through 16 rounds of encryption process. Finally, LPT and RPT rejoin, and final permutation is performed on the newly combined block. The result of this process produces the 64-bit ciphertext. This encryption process steps is further broken down into 5 stages. First one, key transformation, expansion permutation, Xbox permutation, Pbox permutation, XOR, and swap.
Advanced encryption standard. It is algorithm symmetric key block cipher that operates on fixed size block of data. Its key expansion generate a set of rounds from the initial secret key using the expansion algorithm. It performs a number of rounds depending on the size of the key. It also includes subbytes, shift rows, mix columns, add round key, final round. The final state of all the rounds is in ciphertext. Please, Jim. Thank you. Steganography. Steganography is it is a way of hiding one piece of information into another. So it makes it tough to spot. Its main aim is to keep communication secret, not necessarily, but this secret information is hidden within something that looks ordinary, like picture, audio file, video, or text document. When you look at or listen to the resulting file, it seems completely normal, but it actually contains hidden data that you can uncover with the right tools. Thank you.
One of the type of steganography is the image steganography technique. It is a process in which the secret data has been hidden into the pixels of the image so that the data is not been visible to any of the unauthorized users. The resulting image after inserting the data is called as the image stego image. As you can see, ma'am, the flow diagram of the proposed work. First, we have to identify the objects and the requirements. Then the research is done accordingly to the objectives. Then we design a phase. Then the implementation of those objectives has been done. Then the testing and the evaluation is done. If any of the problem is there, then we can then we have to process it again. Then the other is the security analysis, then performance evaluation, documentation and reporting, presentation and deployment.
As shown in figure of architecture, sender sends the file with secret data, which is encrypted by key 1, and sends to the cover media where the embedding process is done using second key.
Sorry to interrupt, ma'am. Please conclude your presentation in next 1 minute.
Okay, thank you. This data sends to receiver side through communication channel. On receiver side data, we'll extract using second key and decrypted using key say first key. Now the data is retrieved by the receiver for reading purpose. As shown in this figure, this is the algorithm which we have used in our project.
Comparison of various encryption algorithm. You can see this graph. The areas that is most efficient algorithms from others.
Its advantages its advantages is enhanced privacy, secure communication, data integrity, also data authentication. Its features promise quantum key distribution, visual cryptography, adversarial machine learning, and security. Thank you.
Thank you, ma'am, for giving us the opportunity to do our presentation. We conclude that our presentation is over. Thank you so much.
Thank you, ma'am.
Thank you for your presentation. Now, next, I would like to call Devanand Doifode for their paper presentation on the paper title, Utilization of Machine Learning Models to Predict the Viscosity of Carbonyl Iron Metal Powder and HDPE Blend. Devanand Doifode and Dr. Sanjay Chikhalthankar. If they are in the meeting, then please start the presentation. Okay. Next call is for Anjane Nigam and Dr. B. Mishra for their presentation on the paper titled Photonic Packet Switching Based Hybrid Optical Switches. Anjane Nigam and Dr. B. Mishra, if they are present.
Hello. Hello, ma'am. Am I audible?
Yes, sir, you are audible.
Just 1 minute, ma'am. I share my screen. My screen is shared, ma'am.
Yes, your screen is visible now.
Good afternoon, everybody. I am here to present my paper, Photonic Packet Switching Based Hybrid Optical Switches, a comparison. I am research scholar in Mahatma Gandhi Chitkot Gramodaya Vishwavidyalaya. Just 1 minute. This is the outline, introduction, optical packet switching, hybrid optical switches, related work and results, conclusion. So, introduction. As all we know that we are living in era of data, and the need of data is increases day by day. It is almost 1.5 times or 2 times every year. So the last technologies that depend upon the copper cable is having very slow speed. So we require the optical fiber communication that fulfill our demands. And in optical fiber communication, we know that the bandwidth is infinite and data rate is as high as 160 Gbps, means Tbps speed can be fulfilled. These are the some advantages, all we know: greater bandwidth, faster speed, longer distance, better reliability. And these are the company. Here, my main motto of this presentation is my switches. That is hybrid optical switches. Hybrid optical switches means where we use the photonic switching. Photonic switching means in data communication, we leave the data in optical form, and only header changes from electronic to optical for the to going the next node. Here more problem is that contention. So for contention resolution, here we use the fiber delay lines. As you can see in switches, there are fiber delay lines 1, 2, and M turns. This is recirculating type, and in next switches, this is simple. So here we compare these 4 switches, switch A1, A2, that are using recirculating type fiber optic, and the switches A3 and A4 is simple switching. These switches have on merits and demerits. As we discussed that these are the some parameter comparatively. Size of AWZ, EDFA, TWC, TF, multiplexer and demultiplexers, storage capacity, and some pros and cons here. Next, speed and time delay. As we've seen that architecture A1 and A2, the fibers are in circulating form, so the delay is less, because as we consider that 0.2 dB per kilometer delay approximately, and when we rotate means we want to rotate 10 times. Or if there is single rotation, then delay is 10 times. But in recirculating time buffer, the data remains in one fiber and rotate many times. So the loss is less and speed maintains. And this is the formula. That's why it's a recirculating time delay. We can control the loss. And similarly, for cost comparison, cost in the sense of number of components, not in the sense of money. So as much as the number of components we use for the switches, the cost is increases. Main costing was TWC. So as we seen in the switches S3 and S4, the TWC here more TWC is needed, so cost is higher. As here we can see that in switches, as A1 and A2, for the 16 number of recirculations, cost is 154.5, whereas S3 and S4, the cost is 170 and 86.5 and 208.5. That depends upon the number of recirculation also. Fiber also increases the cost. And similarly, for capacity it is reverse. As many number of components and storage, the capacity of S3 and S4 is better. So we choose according to our projects which type of switches are needed. We want to extra capacity, or we want to speed, then we select the switches. Okay, thank you, ma'am. If you have any question.
Thank you for your presentation, sir. Now, next I would like to call Dr. Keshav Mishra and Dr. Robin Tiwari for their presentation on the paper title Channel Prediction and Estimation Based on Machine and Deep Learning Techniques, a Review. Dr. Keshav Mishra and Dr. Robin Tiwari. Okay. Now, I would next like to call Aftab Ahmed Ansari and Anbar Ahmed Ansari for their presentation on the paper title Sustainable Energy Integration. Aftab Ahmed Ansari. Okay, next call is for Dolly Thackeray. Next call is for Dolly Thackeray. Please start your presentation on the paper title, A Comparative Study of Routing Protocols and Artificial Intelligence. Dolly Thackeray, ma'am, if you're presenting.
Hello.
Yes, ma'am, please.
Yes. Sometime. Hello.
Yes, ma'am, please start the.
I'm audible now.
Yes, ma'am, you're audible.
Okay. Ma'am, my screen is visible.
No, ma'am, your screen is not visible.
Is this visible?
No, ma'am, maybe you have some issue. Your screen is not visible.
Okay, give me some time.